Okay, so here are the homework answers to proofs number 2. Zooming in on 5 and 7. And then zooming in on 6 and 8. Given triangle KIT is congruent to triangle LOG, the measure of angle I is given, the measure of angle G is given, and the measure of angle O is given. Find the measure of angle O and the measure of angle K. I will get you started on the test. You can choose whether you would like to draw a picture or not. There will not be pictures drawn for you, so it's your choice whether this helps you organize your information or not. KIT is congruent to, let's just do this so I know which one's which, is congruent to, and it really doesn't matter where I put these, LOG, LOG. Now I kind of know which one's matched up because I used my angle markings to mark the corresponding angles. All right, angle I is 2x squared plus 15 degrees. And let's see, angle G, 11x plus 29 degrees. And angle O is x squared plus 31 degrees. So what mistakes a student could make is that they could add all 3 of those to equal 180 because, oh, the teacher gave me 3 things, so there's 3 angles in a triangle, so I'm going to add them to equal 180. So that would be a mistake. Instead, we want to find out which ones are congruent. We don't have 3 unique angles. We have 2 angles that are identical and then one that we're not going to use at all. So if you did draw a picture, that helps. If you didn't draw a picture, you look at the order. I is listed second, G is listed third, and O is listed second. So now I know which ones I need to set equal to each other. I need to set angle I equal to angle O, the measures rather, not the angles, the measures of the equals. 2x squared plus 15 equals x squared plus 31. So that's how you begin that problem. So, was this a factoring problem, guys? Was it a factoring problem? Hallelujah. No, it was not, because there was no x term. There was x squared, but there was no x term. So if I bring this guy over here, I do the minus x squared. I have x squared plus 15 equals 31. And then subtract 15 from both sides. X squared equals 16. To solve for x, we will square root both sides. And what does x equal? This is very important. What does x equal? I didn't ask you for this. X is plus or minus 4, positive and negative 4. Now, wait a minute. Let's look and see if that works. Plug it into each of the options. It works in I, it works in O, uh-oh. Does it work in G? Plug negative 4 in. 11 times negative 4 is negative 44. That 29 is not enough to make it positive. So X is actually just plain old 4. Sometimes you keep both answers and sometimes you throw one out. And this is one of the throw one out kind of situations. Good. All right, so x is 4. Now we simply plug it in. Angle O is going to be 4 squared plus 31. 47 degrees. And angle K, wait a minute, angle K was not one of the ones listed. Angle K is listed first. It's actually not even congruent to any of the ones listed. So we need to plug it into O, which we already did. O is matches with I. So this one's 47. We need to plug it into G, 11x, 11 times 4 plus 29, 73. And now we can use the triangle sum theorem to get our remaining angle K. And that's how we get 60 degrees for K. So the answers were 47 and 60. Excellent job. Next one, given triangle van is congruent to triangle cot, NA is 2x plus 19, CO is 8x minus 56, and OT is 5x minus 26. Same situation, except now you're dealing with sides and not angles. Find the distance from A to V. Find the length of segment AV. Go. When we look at this one this time, let's not draw the picture. Let's pretend you're the student who doesn't draw the picture. So instead, you're going to look at the order, because the congruent statement never lies. It always, always, always tells the truth. NA is listed, let's see, third, second. CO is first and second, and OT is second, third. So I know, just like in the last problem, these two are corresponding parts of congruent triangles. CP, CTC is actually what we're using here. Okay, so we're going to set those equal. And we're going to do a simple solving for x. This one is pretty basic algebra. Let's see, up 3x, and add 26 to both sides. We looking good there? X is 15. And we needed to find AV. AV is listed first. So that's going to go with CO. AV is congruent to CO. AV is congruent to CO. Therefore, if we plug 15 into CO, we will have AV as well. 8 times 15 minus 56 gets us 64. So the length of AV is 64 units. All right, I'm getting some different answers, but it looks like most of you said angle, side, angle. Let's take a look at this one. We were given the information that segment AB is congruent to segment BC. So you can mark that any way you want, but you're going to have to put a tick mark on those sides, and they're overlapping, so you're going to have to kind of show that the whole segments are congruent. Excuse me. This doesn't happen very often. A lot of times our figures are sharing a side. They have a common side, but this time they have a common angle. Angle B is congruent to angle B by reflexive property of equality. So now we can look at each triangle one at a time. And you were right. Angle, here's our side, and here's our angle. So yes, the triangles are congruent, and they're congruent by angle, side, angle. Next one, try this one. Very good. A lot of people are putting the right answer. So we were given some information. C is the midpoint of BD. We know by definition of midpoint that we can add tick marks to BC and CD because segment BC is congruent to CD, like I said, by definition of midpoint. And then the answer is staring us in the face. Yep, it's side, angle, side. It's two sides with a congruent angle in between. Those are not vertical angles, but they were marked that they were congruent, so we are allowed to assume they're congruent due to the markings. So the answer to that one was side, angle, side. All right, next one. Okay, I'm getting a lot of answers. What do you write on the test? Are the triangles congruent? No. And why? There's not really a why. It's not possible. So on the test, just make sure in both blanks you put NP, NP. It is not possible for the triangles to be proved congruent, so we're not going to say they're congruent by NP. We're also not going to write AAA. So on your test, do you write AAA? No, you do not. You don't even say why they're not congruent. You just say it is not possible to prove them congruent. We have a lot of evidence. We just don't have the right evidence. So that one is NP is the answer. Try this next one. Okay, parallel lines are a big deal. They are a big deal and we cannot ignore them. Now, normally I would say, hey, just because they're parallel doesn't mean they're congruent. But in this case, those segments, G, H, and IJ, are both parallel and congruent. They are. So, when we have parallel lines, we can get our highlighters out or we can get a marker out and we can extend them, and we have to find a transversal. don't try to use any of the parallel line theorems, alternate interior angles, any of those theorems without a transversal. Transversal is necessary. So you have to have parallel lines and you have to have a transversal. So once I marked those, now I could mark angle G is congruent to angle JIK because corresponding angle theorem. That theorem says if lines are parallel, then corresponding angles are congruent. I cannot mark anything else. This one is not parallel to this one, so I'm not going to mark any angles where those lines hit the transversal, so be careful. I wouldn't mark anything else anyway because I have enough information. I'm done. I have enough information, and so it's angle, side, angle. Done. You don't keep looking for more things. You stop right there. Next one. Try this one. Also a really important problem. Only one pair of sides are parallel. Let's go ahead and mark what we know is congruent. We know by the reflexive property of equality that that segment is congruent to itself. So we mark that. Then we know that the top is parallel to the bottom, if you want to call them that. And we've got ourselves a transversal. I've taught you guys to make the letter Z out of it. And that Z will show you which angles are alternate interior. When you put the arcs, you should be touching, both sides of the Z. Angle 3 is congruent to angle 4. Angle 1 is not necessarily congruent to angle 2. So we don't have enough information. We are stuck with angle side. There's nothing else after it. So what do we write? It's not possible. Could they be congruent? Yes, but it's not possible for us to prove them congruent. They could be. I wouldn't say no, they're not congruent. I would say, hey, it's not possible for me to prove them congruent because I don't have enough information. All right. Next one, conclude and justify. These you can just write on your paper and we'll just go over them together. Some people have to go. Okay, we'll just start working these out. We'll work them. If A, B, C, and B, D, E are right angles, what can we conclude? Well, if they're both right angles, then we can conclude angle ABC is congruent to angle BDE. And what's the reason? Right angle congruence theorem. Okay. If AC is parallel to BE, conclude and justify. Remember, we need our parallel lines. We need a transversal. I don't see alternate interior angles. Those are not here. I do see some corresponding angles. Boom, boom. And so I can conclude, I'm just going to call it angle A is congruent. This one I have to name with 3 letters, to angle EBD. And my reason is the corresponding angle theorem. Can you just put corresponding angles? No. You have to say that it's a theorem because corresponding angles can exist and not be congruent. But they're congruent because the lines are parallel, and that's what the theorem says. Okay, we're going to skip that one. It's just a different set of angles that are parallel. B is the midpoint of AD. We do this one a lot. What can I conclude? Segment AB is congruent to segment DB. And what's the reason? Definition of midpoint. It's not midpoint theorem. There's not a midpoint theorem that we use. It's definition of midpoint. If BC is perpendicular to AD, then, well, really, all we can conclude, here's BC, here's AD, all that we can conclude is angle ABC is a right angle. And why is that? That's definition of perpendicular lines. It's not a theorem, it's just a definition. That's just what it is. Good. Okay, we're going to do we'll just do one proof, and then we'll end the day. Let's end the day with a proof. All right? Given and prove. Okay. So we make our 2 columns. We've got our statements and our reasons. So let's start with the given. ABC is equilateral. Given. All right, now be careful. Don't say that the angles are congruent. The definition of equilateral is not that the angles are congruent, it's that the sides are congruent. Now, I could say that all three sides are congruent, and I would normally say that, but I'm just going to name two of them because I know I'm trying to prove these triangles congruent, and I don't need that third side. So I am just going to say CA is congruent to CB, and that is definition of equilateral. Boom. Okay, that one's a dead end. I used it. Let's do our second given. CD bisects AB. Given. All right, well, AB has just been bisected. So I know I can go to my picture and I can add markings. And when I add markings, I need to document it. I now know that AD is congruent to BD. Definition of segment bisector. All right, going strong. That one's a dead end as well. We can't go any further. Now, I would normally, solving this problem, I would add tick marks there. What am I really saying when I add tick marks? I am saying CD is congruent to CD. And that is, of course, our favorite property, the reflexive property of equality. I'm ready to say something big. I am ready to say that those triangles are congruent. So let's say it. I have enough information. That's how I know it comes next. Students were like, well, how do you know to write that next? Well, I write it when I have enough information. I'll do CAD. Sorry, that's hard to read. CAD and CBD. Your order might be different. And what's the reason? Side, side, side. Now, this is a different proof than we've ever seen. So we still have 2 steps to go, actually. I'm trying to prove that this angle got bisected. So now I'm going to say that this is congruent to this. This is new. We've never seen this before in our proofs. I'm going to say angle, not triangle, angle ACD is congruent to angle BCD, and that's by CPCTC. Corresponding parts of congruent triangles are congruent. Now I'm ready to say that segment CD bisects angle C, and it's actually the reason is because what a definition of an angle bisector is. So I had someone ask me yesterday, do you have to write converse of the definition? No, you don't. The definition says, hey, if that segment bisects that angle, it creates 2 congruent angles. I'm kind of saying the opposite of that. I'm saying I have 2 congruent angles. Now I know that it's a bisector. So anyways, that was a challenging proof. That was an upper level, more challenging proof. And you'll do your review sheet, and we'll have our test tomorrow.